If you need to convert a fraction to a decimal, it's so simple. You just take the bar in a fraction, which you remember means divide, and then you just solve this problem. 2 divided by 5. You can do that through long division. You can do that with your calculator, whatever way works for you. But that will get you your decimal is just solving that problem of 2 divided by 5. You can also do it using place value. If the denominator in your fraction is something that is close to or like convertible to a power of 10, it could turn it into 10 or 100 or 1,000, etc. Then it's easy to make it into a decimal without having to do any, long division or anything. In this case, remembering that my place value underneath the decimal goes 1/10, 100th, 1,000th, etc. I can see how I could nicely turn 20 into 100. I'm going to times it by 5. Same thing on the top, so I don't change the value of my fraction. And now I have 35 hundredths. Looking back at my place value table, I have to go to my hundredths spot and put 35 in there. But careful, right? We have to carry that 3 on over. This is 35 hundredths, or it's 3/10 and 5 hundredths. So when we write this as a decimal, it's just 0.35. So if you have a number that's easy to get to 10 or 100 or 1,000, this is a really fast way. No long division required. If you're taking a decimal and turning it into a fraction, you're again going to use place value to help. I remember that this is my tenths place, so this is 7/10. Done. So nice. And if I have a more complicated one, I know I've got tenths and I've got hundredths, and finally this is in thousandths. So I can write this as 305 thousandths. Just in case you're wondering, that is the same as 3/10 plus, no hundredths, plus 5 thousandths. It turns into this. It's just faster to write it that way already, though. So if we want to make a decimal into a fraction, use that place value. And then from here, you're going to want to reduce it. But it's going to be a tough cookie right there with that one. When you are adding and subtracting decimals, you have to make sure the decimal points line up. So here I have 1.34 plus 2.7. I have to make sure I line up my decimal points, not the right side of the numbers. That's what we do in multiplying, but in adding and subtracting, we're going to make sure we line up those decimal points. And then any spot that's a blank like this, you can add in a little 0 placeholder. And then we just add like we learned to do long ago. If you're multiplying and dividing, you don't have to worry about the decimal point until the very end. So we're just going to multiply this guy. And then at the end, we will make sure that we put in the right number of decimal points. Before we do that, though, think to yourself, this is about 1.5 times a little bit more than 2. Should my answer be bigger than 1, smaller than 1, bigger than 10, bigger than 100? Like, what makes sense here? And then once you know what makes sense, we can double check. I have 1, 2, 3 numbers that are after the decimal point in my 2 numbers together, which means in my answer, I need 1, 2, 3 numbers after the decimal point. And it does make sense that like 1.5 times 2 in a little would be a little more than 3, right? It shouldn't be 33 and certainly not 337. So great. Our guesstimate sticks with what we've got from our problem. When you're lining up your decimals and they don't, match, as I said, you can add in those placeholder zeros. So 4.8 is the same as 4.8 with any number of zeros after it that you would like. And then you can just start borrowing and subtracting just like you would. If you just have a whole number, remember that has a decimal point after it, right? So when you line these guys up, add in that little decimal point for yourself, and then you can add your place value zeros and subtract again, just like you would normally.